Part 2, Kramer's rule for two equations in two unknowns. Kramer's rule says this: suppose AX equals B is the matrix form of a system of equations where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. If the determinant of A is not 0, then we can use Kramer's rule. The system is consistent and independent, and the solution is given by this right here. What this means is, so X would be, this is whatever variable we're solving for, X, Y, Z. X would be a determinant we're going to call dx for a second, and the denominator here is going to be the determinant of the coefficient matrix. So this determinant, AJ, like this, or I called it dx, we're going to take the coefficient matrix and replace the x column with the constant matrix. So then y, we're going to find dy, which is the coefficient matrix, but with the y column replaced with the constant matrix, divided by the determinant of the coefficient matrix. So let's try that. We want to solve this system of equations using Kramer's rule. So I need to find three different determinants. First, the determinant of the coefficient matrix. So I put the coefficients in my matrix. The determinant would be 1 times -1 minus 2 times 2, which is -1 minus 4, which is -5. So that's the determinant of the coefficient matrix. For the dx, I'm going to replace the x column with the -3, 5, these constants on the right side of the equal sign. Then the y column, I'll keep the y coefficients and find that determinant. So this would be -3 times -1 minus 2 times 5, which is 3 minus 10, or -7. Then I'm going to find dy. For dy, I'm going to keep the x coefficients and replace the y's with the -3, 5, the constant. So this determinant, I have 1 times 5 minus -3 times 2, which is 5 plus 6, or 11. So x is dx over d, which is -7 over -5, or 7/5. And y is dy over d, which is 11 over -5, or -11/5. So my solution, 7/5, -11/5. Use Kramer's rule to solve the system of equations 2x plus y equals -3 and -4x minus 2y equals 5. So to find the determinant of the coefficient matrix, that would be 2 times -2 minus -4 times 1, which is -4 plus 4, or 0. Now what does that mean? If we have the coefficient matrix has the determinant of 0, remember our x value would be the dx over d, and we can't divide by 0. So what that means is that there is either no solution or an infinite number of solutions, and Kramer's rule won't help us find that infinite number of solutions if that's what it is. This one happens to be no solution. But what that means is if the determinant of the coefficient matrix is 0, is that you need to use a different method. Kramer's rule won't work.